we'll move ahead with the next topic. Okay. Already we studied about types of files. Okay, and soft link and a little bit about hard link also, and POSIX file system. So what all Unix and POSIX file systems are there? So what is the relative path and absolute path, how it is given. Then some folders and files. There is some directories. What all things are given? /etc, password, bin, dev. Okay, so those things already we studied. Then 11 attributes. Okay, so each file has these attributes, and we saw the commands. Okay, and system calls for that, changing the sum of the attributes. Okay, then after that we saw the inode number. Okay, so each file has a inode number, and system normally maintains a inode number. That is one inode table will be there in that, so it maintains the all inode numbers. So these things already we saw it. So okay, so next was actually application program interface to files. Okay, so which all applications or for each file for a creation, what is the system call and what is the Unix commands. Okay, those will see it. So now here, so here we listed the different types of files. Okay, so here regular file. Okay, so for to create a regular file you have different Unix commands. Okay, so vi or gedit kind of things, emacs. Okay, so those all are there. So internally it handles the system call. So these all things internally handles the system call. Is nothing but open or create. Okay, and for a directories, okay, so you have a mkdir command. Okay, so internally it has mkdir or mknode system calls will be called. And for FIFO, so mk FIFO is there, and internal commands is nothing but mk FIFO and mknode. Both you can use it for a mknode while creating your u-p option. Okay, so normally mknode will be used for the creation of device files. Okay, so here if you saw mknode is there, this is a Unix command. Okay, so and internal system call also is a mknode only. So device files here, my C and B option you can give it. That is nothing but character or block. Okay, so those device files you can create it. Then symbolic files. Okay, so here we have the ln -s. Okay, so this is a Unix command. Okay, so ln command will be normally will be used for the hard link. For a soft link, -s option will use it. Okay, so internally it has a say sym link. Okay, this is a symbolic link. Normally we'll say it. Okay, for a hard link, it's only link is there. Internal system call. Okay, so and here along with this, always files must open before when before accessing of any application programs. Okay, so if you're writing any application program, so and you want to operate on some files, so always you have to open it first, then only you can perform. And a process, that is nothing but a application. If you are written in that a process is there, means it can maximum open, that is nothing but open underscore max number of files. Okay, so there's nothing but it's one kind of one macro is there, so maximum these many files only it can open it. Then after opening also, so you can perform read and write operations, and these read and write operations, for that read and write system calls we use. Okay, so and if you want to change some attribute, or if you want to retrieve some attribute, what all things are there, for that you will be using the file attribute. Okay, so so for that stat or fstat system call you can use it. Okay, so your stat is nothing but what is the status kind of things, or fstat is your file status, like that. Okay, so what are the attributes, those are there. Okay, so those all things you can retrieve it from these. Okay, and if you want to change it, so different commands. So already we saw those things here. Okay, so before inode number we saw it. So what all things you can change, so these all commands will affect the file attributes. So these things will be affected, like that already we saw it. So here same thing again we are listing. Okay, so chmod, chown, okay, u time or touch, that's API kind of things. So here we will list the system calls. Okay, so link, so these things we can use it. Okay, and if you want to remove some link, that is nothing but unlink will be using. Okay. So internally, so if you saw, we had as a 11 attributes for each file. So those 11 attributes will be maintained inside a one kind of structure. Okay, so here we have say particular data types, and these are the 11 attributes for those data types. And different data types we have. Then so these all things are merged inside a one structure. The structure name is struct stat. Okay, so here if you saw here we have a function also stat. This is a system call. One function is there, the system call is there, and same thing is here we have the one structure also stats one structure also. So this structure actually maintains the all the file attributes. So if you saw these are nothing but your 11 attributes are there. Same thing, that is a file system id, okay, inode number, okay, file type, okay, so and user id, group id, okay, so those all things are maintained here. So whatever 11 attributes are there, those all 11 are maintained in this structure. So this structure only will be retrieved whenever stat system call will be called. Okay, so stat or fstat or lstat. Okay, so here lstat is nothing but for a symbolic link file, so we'll use the lstat. Okay, so whenever you are calling this one, so automatically this content of this structure will be given. So depending on that, you will see the what is the status of that attributes. Okay, attributes of that file. So those things you can retrieve. So one shot you can retrieve all by using these functions. Okay, so here if you are passing a some parameter, depending on that parameter, and there is this is stat is a, if you are considering a system call. For that, if you are passing any parameter, depending on that, you will get the particular values. So those things will be there. Okay, so now actually if you saw previously, we shared about little bit file descriptor. Okay, some inode table, then that is nothing but inode table. You had to say all files which are there inside our system. For that one inode table will be there, and for that file one inode number will be there. Okay, and file descriptor is nothing but each process has the file descriptor. Whichever you are opening the file or you are trying to modify something, for that file descriptor will be there. So there should be a connection how you have to open it, or how you have to close it, or read and write operation you have to perform it. Okay, so how it will happen, that we'll see now. Okay, so what already we studied is a file descriptor. Okay, so each process will be having the file descriptor. Okay, so here if you saw this will be given as here process space, but it's something but inside a process you have one file descriptor. Okay, so this file descriptor table is there. Okay, so here this table contains, so whichever file you are opening it, for that related entry will be there here. Okay, so a process can open maximum open underscore max number of files. Okay, so consider as a 255. Okay, so it depends on the version again. Okay, so for 6.1 it supports 255 files it can open it. So consider that this table has a 255 entries. Okay, so all are not used. Okay, so it has a just nothing but 255 entries maximum it can have it. So how many files you will open it, those many entries will come here. Okay, so this is the file descriptor. Whenever you are opening a file, that will come out. Okay, then this will be maintained in the file descriptor. Then if you saw as a in a system one table is there, that is something but here inode table. Okay, so whatever files are there, for that you will be having a some number, that is inode number, that will be maintained. Okay, this is the table is there. To connect these two, kernel maintains always a file table. Okay, so this is a kernel, in kernel space we have as a file table. So this inode table also will be there in kernel space only. Okay, so kernel one more thing it maintains is a file table. It's nothing but currently which all files are opened. Okay, so here these are the files are there inside my system. Here whatever you are trying to open it in currently inside a process, that is a file descriptor table. Now currently which all files are opened inside my system, that will be maintained by file table. Okay, so here you have as a completely file table. So if I have as a 10 applications are running, okay, and so in that suppose 5 applications are opened one file each. Okay, so here you will get as a 5 entries. Okay, and like that here if you saw here I have told as a 10 applications, 10 processes are there. Okay, so it means like this 10 tables will be there. Okay, so if each process is opening a file, means for each from each table you will be having the one arrow here. Okay, so what is that arrow, we'll discuss it. Okay, so you will be having some kind of arrow. If that the process is not referring any file, means you will be not having any arrow mark for the file table. Okay, so this is nothing but currently how many files are opened. Okay, so that entry will be there. here how many in system, what all the files are there, that entry will be there here for each process. Okay, so for each process this table will be there. Okay, so now how it will map. Okay, so how we will access whenever you are trying to open inside a process, how it will physically it will map it until this point. Okay, so that will see it. So so here suppose consider say one process. Okay, so file descriptor we have, so it's opening a one file in a read mode. Okay, so what will happen is, so that time if from here file descriptor one file it's opened, so read mode, so from here one kernel will try to open it, that is something but open system call you will call. Okay, so that time kernel will see that path and it will convert that path to the actually it's inode number. Okay, so that already we saw it, that is nothing but slash joe slash user kind of things, so already we saw it. Okay, so how it will convert is, that is a u area, inside that you will be having the inode number, then inside a folder again file number, file name and corresponding inode number will be there. Okay, so those it will access it and it will link it to the actual inode number of that file. Okay, so here in kernel whenever you are trying to open a file inside a process, so automatically kernel will identify the inode number of that one depending on the path whatever you given. If that process has the all the specifications related to the permission, okay, so it's something but it has all the privileges to open it and read it, so kernel will allow that one, otherwise it will throw the error. Okay, so here suppose consider say we have all the permissions whatever required to open or read or write whatever task you want to do it for that. So now suppose here you are opening for a read mode, so it will check it. So now entry in this table will come. Okay, this is a file table, so here in this table one entry will come related to that inode number whatever we identified. Okay, so and here one count will be kept. Okay, that is rc. Okay, so what here one count we are keeping is nothing but we are saying as a, this is a reference count. rc is nothing but reference count. Then here we are making as a one process is trying to see this file. Okay, so now it means now because this is a read mode. Okay, so it's nothing but it's trying to read this file. Okay, reference count, how many processes are referring it. Okay, so one count will come from this table to here actual physical. Okay, this is physically actually you have the where location is there, then their corresponding inode table is there. Okay, so where it is there that inode number it will refer it. So whatever inode number you identified here, that is the inode number will be there inside this table, it's particular it's referring it. So this inode number is nothing but actually you have a one file that is considered as a xyz file. Okay, so this file physical address will be there, physical location will be there. Okay, so this pointer physically whatever is there file starting address, it will be given to the file table. Okay, so just I will revise it once again. So here whenever you will open it, file descriptor, okay, so depending on the path it will find the inode number, kernel will find the inode number. So in this inode number will come. Okay, so this inode number it will see it in your inode table. Okay, so corresponding to that pointer will come. So in this whatever this inode number is there, that is nothing but physical entry of that file will come here. The side somewhere it's kept it physically that file, so that entry will be there. Okay, so that starting address of that file will be given to the this file table. Okay, and here also one reference will be maintained. Okay, so there is something about reference count will be maintained, that is something about how many processes are trying to maintain how many entries from the file table to this file is there. Okay, so that is it will be maintained here. So we have as a one. Okay, suppose this process only now is trying to open second file. Okay, so that is nothing but abc file. Okay, so once it's opening in a read write mode, this is nothing but rw is nothing but read write mode. So here from here to here we got the reference, that is nothing same whatever we explained here, same way we got the reference, and from here to that actually abc file we got it. Okay, then again this process only after some time it's opening again same file, that is abc file in write only mode. Okay, so that time again in a file table it will come here as a write mode. Okay, if you saw already same file is opened here read write mode. Now this process again it want to open it in same file in write only mode. So in file table again one more entry will come. Okay, but in inode table this is a physical existence of this file is only one. Okay, so it will keep as it is. Okay, so these two cells are pointing to the same physical location inode table. Okay, so inode table, whatever entry is there, row is there, it's pointing to the same thing. Okay, and here if you saw now how many references are there, there's a two. There's nothing but how many things are pointing from the file table. Okay, so two things are pointing to the from the file table to the this inode table. Okay, so it will come as a two. And if you saw here, only one process is trying to read and write this file, so reference count is one. And here only one process is trying for a write mode, so this is a reference count is one now. Okay, suppose one more process is there. Okay, that is also is trying for a abc file only. Okay, that's considered as in write mode. So here one more entry will come, that is a, it will come as a, that is a sorry, here already existing is there, so that will be given. So here reference count will become 2. Then here this already these two had, now one more process came, so that's why it will become as a 3. Okay, so like that it will increase it. So how many entries from this is coming, that is here it is a 1 plus 2, that count will be increased here as a 3. So how many things are pointing here, so those things will be there. Okay, so like this will be there. Okay, so this is how it will open it. So there's nothing but how you will get the link, there's something but if you got the link means you are opening that file. Okay, so that is only we written here. Okay, so in description we written it, just we'll go through it. Okay, so whenever open function will be called, what all things will happen. Okay, so first again it's a file descriptor table, search user entry is there or not. There is nothing but maximum number of files you opened or not. If it's unuser entry is there, means you can open new file. Otherwise if it is already full, means maximum entry you reached, you can't open a new file now again. Okay, so it will see for unuser entry. If it is unuser entry is there, means then it will return something you want to return it, that is index will be returned. Okay, there is nothing but here file descriptor number it will return. Okay, so that is in handler, file handler normally will say it in programming, so that is nothing but here file descriptor number you will get it. Okay, then it will scan for a file table to find a unuser entry. Okay, so here in this unuser entry whatever is there, it will try to insert there. Okay, that is then file descriptor table entry will point to the file table entry. So whatever entry will identify in that, it will point it. Suppose here to here we got the entry, so it will point it. Okay, so then a file table entry will contain the current file pointer of the open file. Okay, so here now sorry. Okay, so here now you will get the pointer of a current file opened. This is nothing but from here whatever I was saying, this is a physical location starting address. Okay, so that you will get as a file pointer, so you will get the file pointer there. Okay, then file table entry will contain an open mode. Okay, so in this whatever open mode you specified here, that will be given. Okay, so if it has the particular read write permissions for this file, so it will allow it, otherwise it will throw the error. Okay, okay, so that is something for read only, write only, or read write operation, whatever is there it will give it. Okay, then reference count will be increased. So here reference count it will increase it. So here reference count entry, so because it's a unuser was there, a new one whatever you are adding it, reference count it will set to the 1. Okay, then reference count in the in memory inode number, okay, that is will be increased. So here if you are added, it means it will increase here. Okay, so increment by 1. Okay, so this will happen it. So this is how file will be opened. Okay, so now next what all things will happen for read and write. Okay, so read write, and then what all things will happen, close, all those things we'll see it. Whenever you are going for a read operation or write operation, what all things will happen, we'll check it now. Okay, whenever you are calling a system call or any API of read and write for any file already opened, because you have to open it here. Okay, then only you can perform a read and write operation. Okay, so if you open, what all things will happen, the file descriptor is the first argument to read and write system call. Okay, so you have to send the file descriptor whatever you have here to, you got the handler in say. Okay, so that you have to pass it. Okay, then kernel uses the file descriptor to index the file descriptor. Okay, there's nothing but table to find the file table entry. So kernel will see whatever FT you got it from there where it is pointing. Okay, so it will see it here. Okay, like this from here whatever file descriptor entry you took it for the system call, that will check it, that fd to where it is pointing, that will check it in a file table. So after that it checks the file table entry to see a appropriate mode. Okay, so whatever, now if you are trying to read it and its mode is read only or write only, okay, those it will check it. So if appropriate mode is there, then it will allow it, otherwise it will throw the error. Like for example, if you open the file for a read mode, now you are trying to write it. Okay, so that is a whatever entry is there here, is it a read only or write only or read write, or whatever mode is there, that will check it. If it is appropriated there, then it will allow, otherwise it will throw the error. Okay, permission, it will check it. Okay, so then use the file table entry to access the file node in a record. Okay, so from here to here it will find the, because you want to read it or write it, so actual physical location you have to go. Okay, okay, so it will check it for the here inode table. Okay, so from here it will check the inode table entry, then file pointer in the file table entry to determine where read and write should occur. Okay, so here you will be having the one pointer, so it's pointing, so from the which file you have to do it. So then here you will be having the pointer. Okay, there's a file pointer will be there, so that pointer you have to check it where you have to start the reading or writing thing. Okay, so that will start. Okay, then check the file type in a inode record that invokes the appropriate driver function. Okay, so here depending on this, here you will be having the inode table. It has a inode number and corresponding driver information also. Okay, so why driver information is, if you are opening a regular file, it's no problem, directly you will communicate with your memory only. Okay, so sometimes you will open device files also. Okay, so that time device drivers has to come in picture to write something. Okay, because all things whatever we are doing is in terms of process, it's nothing but an open call only, because our Unix system sees all the things as a files only. Okay, so here you have to get the driver information and particular driver, how it will communicate to that actual device or actually your memory, whichever you are trying to write it or read it, it will come in picture. So depending on that pointer, it will start reading or writing it. Okay, so it may be a buffer wise or character wise, so it will do it. Same thing it will perform then operation. Okay, sometimes we will use lsic system call. Okay, what is lsic system call is something what just you are moving your pointer from one place to one more place. Okay, so suppose the entire one file is there 100 bytes, so starting 0th location it is there, but starting 10 bytes you don't want to read it or you don't want to perform anything. Okay, so that time lsic you will use it to move ahead, or sometimes if it is a file pointer is in the 50th location, if you want to move back also, so that lsic also you can use it. Okay, so depending on lsic how it will operate it, that we'll see it now. Okay, so here what will happen is invoke to change the file pointer. So here whatever file pointer will be there in the file table. Okay, so it will see the to change the file pointer to different offset from the next read and write operation. Okay, so whatever you are invoking is, that is wherever it's left, always you will be pointing to the next location. So invoke that one and check it what is the current location now. Okay, the kernel gets access to the file inode record and checks that the file is not a character device. Okay, so because if it is a character device or sorry, okay, is not a character device file, a FIFO file or a symbolic file. Okay, so if it is a character device file or FIFO file or a symbolic file, okay, so lsic will not operate on those things. Okay, so there continuously or serially you have to read it or write it. Okay, so in between you can't do the operation on read and write. Okay, so that's why it will check it for it's a character device file or FIFO file or a symbolic link file. Okay, if file type is compatible, that is nothing but not of these things. Okay, if it is a regular or a binary file, then change the file pointer to the value in the lsic. So whatever lsic value will be given, for that it will here file pointer whatever is there, that will be modified. Okay, so in this it will be modified depending on whatever it's pointing it. Okay, so here you will get the actual file type, will get it in inode table. Okay, file table will be having the only, this is the reference to the inode table, but file table will inode table will be having the file attributes. In that file attributes, first one is the file type. Okay, so that it will refer it. Okay, depending on this inode table, it will check the attribute, then it will allow can we perform lsic or not. Okay, then whenever close will happen, system call will call it. So what all things will happen? Okay, so kernel will set the fd entry to be unused, that is file descriptor whatever is there. So here this will remove it. Okay, first thing it will remove it, then decrease the file counter. So whatever counter was there here, it will decrease it. Okay, so and if it is a still non-zero, okay, so if it is non-zero, non-zero, then it will go to the sixth is nothing but return successfully for that particular whatever process you call as close, successfully closes happened. If it is non-zero, okay, so suppose if it is a zero, then something else you have to do it. So what we have to do is here file table entry is marked as an unused. So here if it is become as zero, this count has become as a zero, so you have to remove it. Okay, so this entry will become more than one. There is nothing but if more number of processes are trying to access the same file with the same mode. Okay, so that time only it will come. Or maybe this process child, okay, so that time it's accessing the same thing, two processes. Okay, so parent and child both are accessing to the same file, so same read mode or write mode will be there. That time it will increase this count. Okay, so if it is a count is become zero, so means all the processes are closed this one, so you have to remove it from the file table. So currently no one is accessing this one. Okay, so you have to remove it. So you have to remove it from the your file table. Okay, then decrease the counter in the here also. So whatever, if you remove one entry in file table means you have to decrease here. Okay, that is inode table, you have to decrease it. Okay, so then if inode table entry is one, okay, if still is not zero, so that is something what here if it is not a zero means there's something what you successfully executed. Okay, so if hard link count is there, okay, so that would difference with this one, that is nothing but here inode in that reference count. Okay, so inode reference count is nothing but because here in inode table how many files are there, that will be there. And here if you don't have any reference count means, okay, so if the hard link is there, uh, inode inode is non-zero, then return to the caller. Okay, so if the hard link count, that is whatever file will keep it for that hard link always, whenever you create it, it will be one. So how many links you will create it, depending on that value will keep on increasing. Okay, so here if the hard link count of a inode is non-zero, the return it as it is. Otherwise it mark the inode table entry as a unused. So it's nothing but this memory, whatever is there, there is nothing but you have deleted that file itself. Whenever inode the hard link count will become as zero, so it means this file itself is not required. Okay, so that is here if it is inode table entry is unused, and deallocate all the physical disk storage of the file. Okay, so there is nothing but this in from here whatever file actual location was there, deallocate the all the memory. It means you don't require that file only. So when this part will happen is whenever you are using rm command. Okay, so or any command which deletes the file. Okay, so inside maybe in your process or any application you are doing it. So if you are using any rm command or in any application you are deleting it something, so that time inode count, sorry, hard link count, if it become as a zero here, it means you don't want to use this file inside your system. Okay, so that time you have to delete this file. Okay, so if it hard link count, if it is become as a zero, so automatically this file is no more longer useful for inside our system. Okay, so what we have to do is we have to deallocate the memory. Okay, so here what we'll do is, so automatically we will deallocate the memory. Then path also it will be removed. So whatever directory path will be there, so those path also will be removed. So and in each directory file you will be having the inode number and corresponding file name, so that also will be removed. Okay, then after that it will send the successful. Okay, so after that step number 6, that it will send the successful to the function which calls the close, sorry, process which calls the close. For that it will return the successful. Okay, so these all things will happen. So whenever you are doing a for a one file, that may be a open, read, write or close, any operation you perform it, so these three table will come in picture. Okay, so always you will be having the file descriptor, file table, then inode table. So from this actual physical device, a physical location wherever file is there, that it will point it, then all things will perform. Okay, but pointer will be kept inside a file table here. Okay, pointer will be kept inside a file table, not in inode table. Inode table you will be having the inode number and corresponding attributes that when you can access it, all those things. Okay, Okay, so next we'll go for this is C stream pointers and a file descriptor. Okay, so till now whatever we are saying is here with respect to system call open, if you given as a file descriptor, you are getting it. Okay, so if you observed in some times while writing a C program, normally a stream pointer will use it. That is nothing but file pointer. Okay, normally we'll use it. So what is difference between file descriptor and this one? There is a stream pointer, normally file. Okay, so here whenever you are opening a file, okay, so in C, okay, so there's nothing but in C there's a standard they provided. Okay, so f open, you have to use it to open a file. Okay, so if you have as a file descriptor is nothing but directly you can give as a open, only open system call you can give it. Okay, so and this stream pointer is there are two things. Okay, so here file whenever you are using it, so and if you are using it continuously, that is a bulk of some buffer that you want to write it continuously. Okay, and you sequentially you want to perform some read and write operation, that time this file pointer will be useful. Okay, and file descriptor some frequently want to use it, and if you want to don't want to use a buffer, okay, there is a small size of data you want to perform it, so that time this will be useful. Okay, so when these things are more efficient is nothing but here sequentially you want to perform some read and write operation. Okay, so that time file will be useful, because file internally what it does is it internally keeps a one buffer, then entire buffer will be returned to the that whatever file is there, actual file, physical file we have. Okay, so actual file whatever will be there here, so for that it will be directly, it will be written. Okay, and file capital letter whatever will write that file, that is something what is some kind of pointer. So internally whenever you are using that one, buffer will be maintained, and that buffer entire thing will be written. Okay, so but with respect to file descriptor, now whatever we saw, this is with respect to file descriptor only. So whatever read and write operation we are doing it, so like this it will take the path and it will directly read it or write it. Okay, so here we don't have any kind of buffer. Okay, so this is a more faster way, but whenever you have more things you want to write it, this is not a good thing. Okay, so nothing but sequentially if you want to write a more content means this is faster, because so one shot you will be writing the more memory locations here. Okay, so here one by one you have to write it, so it will take more time. Okay, and depending on the situation, sometimes this is the efficient, sometimes this is the efficient. There is nothing but if less number of bytes you want to read it or write it, file descriptor will be the efficient. And if you want to write a more number of bytes, so that time file pointer this will be efficient. Okay, and one more thing is here this file descriptor concept. This concept is there inside Unix and POSIX.1 component systems only. Okay, so in this only it's there, but this what this file pointer is nothing but here C stream pointer, this is a file pointer. So this has been supported in all the operating systems. Okay, so it may be a kind of Windows or DOS or anything you want to use it, so all this is supported. So it's a standard version of C they provided. Okay, so how they have to communicate to the file. Okay, so that is given, and this is a operating system is given. Okay, so that is the operating system of Unix and POSIX. Those things are given it here for a file descriptor. Okay, so okay, so these things already we have discussed, I think. Okay, so you have open, so it will return it. So end of file, depending on the it will take the buffer and it will read it. Okay, error status, end of file, these things it will check it. Okay, so normally, okay, and C library functions. Okay, so here for C library whatever we are discussing here, file related thing. So you have f open, f read, okay, get C, get scan, get s. Okay, f write. Okay, so f seek, f tell, f rewind, these all things we will use it. But with respect to Unix we have these system calls only. So these are the different functions we can use it in with respect to sorry, file C stream pointer. Okay, there is a file pointer normally. Okay, so we can use it these all functions, but in Unix system call we have only these things. Okay, so open, read, write, seek, then close, these things we have it. Okay. So next one is directory files. So here directory files actually this has normally whenever you are creating it, it has only two things inside that directory files. There is nothing but, so what is the file name and corresponding inode number. Okay, so in that directory, so how many files are there, those files information will be there. That is nothing but we'll be having the inode number of that and what is the file name. Okay, suppose one directory has the two files, that is xyz and abc. So xyz inode number will be there and abc inode number will be there. Only that file directory file will be having these things. Okay, so how you can create it or open it, these are the different things you have it. Okay, so to open a directory, normally you have the open dir. Okay, so read dir functions. Okay, so these are the different functions we have it to read it. Then for a closing purpose, rewind. Okay, this is nothing but normally like pointer will be there whichever file you opened. Okay, so in that how many files are there, sorry, directory file if you opened, how many files are there, one by one it will be keep on reading it. Okay, so if you want to keep it in the beginning, okay, that pointer will set it. To send set that pointer, we'll be using the rewind dir. Okay, stop here.